Use the limit definition of a derivative to find f prime of a, where f of x equals 3x squared minus 5x plus 2. First thing we should do is write down the limit definition of a derivative. And there's two ways you typically see it presented. One of the ways is this: f prime of a equals the limit as x approaches a of f of x minus f of a divided by x minus a. Let's look at a graph of the function. So we see it's a parabola. And what is this limit definition saying? It's saying that if we have some point, say maybe this point on the graph right here, and we'll say that that has an coordinate of a on the x-axis, and then we have another point, say this point right here, and that has a coordinate of x. What we're doing is we're letting x approach a. In other words, we're moving that point down along the curve and getting it closer and closer to this other point, but not on top of it. And we're calculating the secant line, the slope of the secant line, and as we bring that point closer and closer to this point, we see that the slope of the secant line approaches the slope of the tangent line. Okay, so let's actually do the calculation. So f prime of a is going to equal, so we have the limit as x approaches a of f of x. Okay, what's f of x? That's easy. That's just 3x squared minus 5x plus 2. Great. Minus f of a. What's f of a? Well, you just take f of x, and everywhere you see an x, you put in an a. So we have 3a squared minus 5a plus 2. And then all of that is divided by x minus a. Okay. I have to keep writing the limit out front up until the point where I actually take the limit. So I haven't actually done the limit yet, so I'm going to keep writing limit as x approaches a. And now let's see, what can we do here? Well, I have a plus 2 here, and that's going to end up being a minus 2. So it looks like those are going to cancel. So I'm going to have 3x squared minus 5x minus 3a squared plus 5a, and plus because I have a minus here and a minus here, all over x minus a. Okay. Again, have to keep writing the limit because I haven't yet taken the limit. So the limit as x approaches a. All right, now we have to do a little bit of algebra here. Let's see. I see that I have a 3 I can factor out of those two terms, and I'm left with x squared minus a squared. And then I also see I have a 5 here. In fact, I'll pull out a minus 5. And then I'm left with x minus a. Now, why is that? So if I pull out a minus 5 here, this is going to become negative. I mean, imagine multiplying this back out. You get minus 5x, that's that term right there, and then plus 5a, that's that term. And then still have the x minus a in the denominator. Okay, again, got to keep writing limit because I haven't yet taken the limit. So limit as x approaches a of x squared minus a squared. That looks like difference of two squares. So I'm going to write that as x plus a times x minus a minus 5 times x minus a all over x minus a. And now what do you notice? I have an x minus a here, x minus a here, and an x minus a in the denominator. They're gone. Okay, so this is the limit as x approaches a of, so this is going to be 3 times x plus a minus 5. And that I can take the limit of. So the limit as x approaches a means that this is going to be an a plus a is 2a, 3 times 2 is 6. I'm going to get 6a minus 5. Okay, so that is one way to do it. Remember I said that there's typically two ways that you see the limit definition of a derivative presented, and you can use either one, but I'll show you the other one just so you can see how that would work. So here is the second definition, and it says f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a over h. And you might see different textbooks use different letters other than h. Sometimes you see a delta x in there instead of an h, but it all boils down to the same thing. So graphically, what this is saying is that if I have a coordinate, let's put, how about here? And we'll call that A. And I have another coordinate here, and I'll call that A plus H. Then the distance here across between the two of them, that's H, because I have A here, and then I have A plus H. And I'm letting H shrink to 0, which means I'm essentially bringing this point closer and closer and closer to the other point. You can see it's very similar to the other definition. Okay, let's calculate it. So f prime of a is, and same thing as before, keep writing limit out front up until the point where you actually take the limit. So this time it's limit as h approaches 0 of f of a plus h. Okay, so I have f of x. The way this works is everywhere you see an x, you replace it with a plus h. So that's going to be 3 times a plus h squared minus 5 times a plus h plus 2. And then minus f of a. 3a squared minus 5a plus 2. And this whole thing is all over h. Okay. So now I have to simplify this. So I'm going to do it over here, make sure I have enough room here. This is kind of a long expression. Limit as h approaches 0 of 3 times, and now I have a plus h squared. So I'm going to multiply that out. In fact, I'll multiply it all by the 3. So I get 3a squared, and then I'm going to have 2ah terms. So that's going to give me 6ah when I multiplied by the 3, plus 3h squared. If you need to multiply this out first and then multiply through by the 3, that's okay. Better safe than sorry. And then we have minus 5a minus 5h plus 2 minus 3a squared plus 5a minus 2. Okay, distributing that minus sign. All over h. All right, I think I see some things cancel here. 3a squared minus 3a squared. Minus 5a plus 5a plus 2 minus 2. Let's rewrite it and see what we have. So we have the limit as h approaches 0 of, so I have a 6ah left over, I have a 3h squared left over, I have a minus 5h left over, and I think that's it on top, and then I still have h on the bottom, and now I have an h in each term that I can cancel out with the h on the bottom. So if I do that, I'm left with the limit as h approaches 0 of 6a plus 3h minus 5. And now I'm ready to take the limit. As h approaches 0, this term is going to go to 0, and I'm going to be left with 6a minus 5, which is the same thing we had before.